Welcome to the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. Hi everyone, my name is Joris Peels, and this is another episode of the Prosthetics and Orthotics podcast with Brent Wright. Hi Brent, how you doing?
I'm really excited about this podcast. This has been a long time coming, and I'm excited about our guest.
Okay. So who do we have on today, Brent?
All right. We have Dr. Gerald Stark. He also goes by Gerry to most people, I would say. He's been in the field for a long time. He's the director of clinical affairs for Ottobock. I'm super curious to hear more about his dissertation around the innovation side of things for his PhD. He is a wealth of knowledge in all things prosthetics, but definitely was a upper extremity specialist, I would say, and then really has embraced this clinical affair role. And the other really neat thing that he does is he really focuses on the health of people that work in companies. So he wants to make sure they have mental health, healthy health there too, which a lot of times is left out of the orthotic and prosthetic industry. You know, historically, people burn the candle at both ends, seeing patients, doing lab work, smelling glues, resins, all that stuff. And I think there needs to be an end to that. Gerry, thank you for coming on the show with us.
Well, thank you, Joris. Thank you, Brent. Thank you for involving me with your discussion. Yeah, thank you so much. And yeah, your introduction is kind of interesting because as I started my profession, I was a mechanical engineer, so I definitely was interested in the innovation and how that helps patients and helps prosthetists. But as time went on, I realized I was reading an article one time about upper limb prosthetics, and I found out that the acceptance rate in 1958 was almost the same as it is now. And then I realized that maybe there was more to the people that put these on people and the people themselves. And then I became kind of interested in how people adopt innovation, how they reject innovation, and those things that as clinicians, we imprint on the patient themselves. And I realized that the state of the mind of the caretaker is very important too.
I think that's a really good point. I mean, I think, and I always like, do you think it's a especially stressful job, this? Because it does seem, for me, I don't know anything, right? That's the whole point of this podcast. I don't know anything about the orthotics or prosthetics. Brent knows a lot. We both love 3D printing. We're kind of exploring where it comes together. And, is it a particularly stressful job if we compare it to like being an accountant or construction worker or something like that?
Well, in terms of like an emergency room doctor, not that level. But I think with the real big issue, Joris, it's that the practitioner has very little control. I think that we lead a schizophrenic life in a way because they have very little control as to how they get paid or how they're measured. As clinicians, we measure ourselves in terms of how effective we are and what we do. And we're even willing to endure discomfort, pain even. But the thing is that sort of, when we try to make things better, we try to make them function better, that's not really reflected necessarily in terms of what the revenue, not correlated to the revenue you generate. And unfortunately, that's how you're evaluated by your upper management, regardless of what company you're in, even a small owner-led company. So it's this kind of schizophrenic, we value ourselves one way versus how the world views us and values us. So in a way, it's sort of like engineers, right? Engineers, you can bonus them, you can incentivize them, but they mostly want to know that they're effective and respected by their peers. They'll certainly take the bonus money if you give it to them, but they're really concerned about how they're viewed as experts. So that's kind of like engineers are kind of like clinicians, and at the same time, marketing and sales is bonused by public accolade and also financial incentives.
Yeah. Do you also think that's a problem? Because, well, the thing is, like, let's say we're looking at an accountant working in a firm, like, her job is much more kind of the same job all around, right? And she maybe has to present it, do some commercial stuff at one point in her career, but mainly later in her career, probably. But a clinician has to work with patients really well, do the engineering bit, do a little bit of commercial, maybe a bit of sales, and do their own accounting. Especially in a small firm, this seems like it's something like, you need kind of like really kind of like multi-faceted human being to make this all work.
I mean, there's two different main areas of any company. There's the techno-processual group. They're engineers, industrial people, accountants. Then there's the human relational people. There's sales and marketing and human resources. Clinicians really ride right in the middle of all of that. So they need to view the patient sometimes very clinically and not necessarily listen to everything the patient's saying, but then evaluate them in terms of engineering. And then the flip side, they need to make sure that they don't just think that just because they provided something, they can just kind of give that patient and not say anything. They have to have a relationship with them. So I think it pulls them back and forth. Accountants are typically retrospective in their view. They look at everything from the past and how it formulates to the present and then the future. But they're gambling on things that things were the way they always were. That's why black swan events kind of upset accountants. Accountants are also process people. They have one job and it never stops. Whereas, practitioners, we tend to be more project based. We have a beginning, middle, and end to that project. Even though we retain our prosthetic patients for our lifetime, they just keep coming back.
I think that's a really exciting perspective. Also, because you were talking more of mental health, but also to me, it sounds like it's all fun and games having your own little workshop, working with carbon fiber and stuff. But I also think that there's a health and safety, kind of a physical safety element to this as well, right?
Right, exactly. We have to make sure we provide things that are safe for the patient long term. We have to really look and understand what they're doing. For instance, a patient will tell you they barely go in the water, and then you see every evidence that there's salt in their prosthesis. And then by the time you really inquire, you realize they do go into the water quite often and they're up. So there's this idea of what they think they do and what they do. And this is really critical because we have to know about material science that, the type of aluminum we use, for instance, is prone to breakage under weight in salt water. So that's why it's important to get the patient's entire context. So it has to be safe. We have to make sure that they're safe. But we also have to think about what it will take for them to fully utilize this prosthesis because it's not just a tool or instrument. It becomes part of them. We have to really think about this phenomenological osmosis. They adopt it as an extension of themselves. And this is nothing new. We do this all the time. If you have your favorite car that you're driving, it's an extension of you. It's a kinesthetic projection. It feels right. But when you drive someone else's car, nothing feels right. To a prosthesis, this is even more poignant. The brain is so adaptable. There's experiments at Georgia Tech that the brain can adapt to having a tail. How cool would that be? The brain can develop this kinesthetic projection to having a tail. So a prosthesis is very similar, or orthotics for that matter.
Mm-hmm. Yeah, exactly. But this has really excited me, this idea, because it means that literally, okay, I was thinking of this idea of the perfect prosthesis. Now, of course, it doesn't exist, right? But the thing is that the prosthesis changes the patient, right? So you're talking about going in the water. If the prosthesis is lighter, or if you tell them, hey, you can go in the water with this, Sarah, go for it. She's going to go more in the water, right? That's going to change the prosthesis, but also her body, Maybe she get more muscles in a certain. So there's this continuous interaction, this feedback loop into the functioning of the prosthesis and the patient and how much it feels like a part of their body, and indeed how much they do with it.
Exactly. And not only does it change how the body is, it changes the brain. And when I say change the brain, I don't mean just in terms of architecture. I mean, physically changes the brain. It's not just cognitive. They show this that, in different things like a taxi cab driver in London, their upper lobe of their hippocampus was bigger before they got GPS. When they got GPS, it got smaller. I think this changes the architecture of the way they use their prosthesis. So the sensory part of the cortex overlays the motor cortex. And this is what therapists do so well is they overwrite that, right? They just have them repeat movements with an arm prosthesis so that it becomes part of their kinesthetic memory, their motor memory. But we see this all the time. And when the perfect prosthesis is when I see it incorporated into the body image, when I see the patient talking with their prosthesis or pointing with their prosthesis, they don't have to do that. But when they're using it as part of their language center, or they're using the lower limb to kind of manipulate things more, that's the perfect prosthesis because they brought it into their sense of being. And I've seen it both ways. Mm-hmm.
No, but well, to me, it's interesting to see if like, okay, yeah, but does that mean it needs to like? Would that mean that one, we can do a couple things. We can make it look, we can make it function better, which will mean we'll use it more, and then the brain will be like, oh yeah, this is good. We're doing this right. So I need to learn more about this new plasticity, this new element, this new tool, finger, whatever. Or do we make it look as much as possible like a finger? Because then I'll kind of be fooled into thinking it's like a finger. Or do we make it like as cool as possible, which is now the trend to make it like personal? You know, it looks like Spider Man or whatever, and we're going to like it more. Or is it kind of all the above?
Well, that really depends on the patient. Again, they each have different levels of need, also cultural differences. In Europe, it has to look like a hand. It must look and feel like a hand to kind of fool the brain just a little bit. In the US, culturally, we've adapted to more of the tool shape. But here's the thing, and there's other studies that show this. When it is a tool, they begin to regard it. We looked at my electric hands. They regarded those as really an electronic tool. But when we engage the thumb, now everything changes because the thumb is so integral. It's about 25% of the cortex. We find is that the brain gets fooled just a little bit. It actually functions and looks like a hand. One of my patients said, with one of these hands that the thumb moves, his wife said for a moment she forgot that he was a prosthetic wearer. And it was just simply because the thumb moved in a very lifelike way. We know that when a hand moves at 300, 200, at least 200 millimeters a second, we begin to kind of leap that chasm where the brain begins to accept that movement a little bit better. But it's not just fooling the brain, it's also giving it the ability to manipulate things. So it's kind of like those choices that the patient makes.
Well, did you say the cortex, as in the cerebral cortex, which is everything that's like speaking and
Yeah, the
understanding the world
hand
around
is,
me?
yeah,
A quarter of
yeah.
that is my thumb.
No, right. Your thumb, your hand is neurosynaptically connected to your language centers. That's why we talk with our hands. And humans have evolved in this way because, when we were on the savannah roaming around, we had to talk with our hands, but we also had to talk with our hands because our hunting partners usually were about 100 feet away from us or 100 yards. So signaling with our hands became integral into our language centers. So the ability to move your thumb, in a sense, people who use a hand speak with a body language lisp. They don't have an extra hand to express themselves. So that's why like upper limb is a little bit different than even lower limb. It's typically more passive in nature. But we're finding that this cognitive integration is also important for orthotic wearers and lower limb prosthetic wearers in how they target the use of their limb, not necessarily ingrained with the language centers, but in terms of mobility. We're finding that socially people pick up on this, right? You pick up on if someone has a limp just inherently, but if the patient's able to walk more efficiently with a narrow base of support, you adapt to them. They become part of your social group more easily.
Yeah, but does that also mean, because we've talked about this a couple times before, this like, so how do we activate that in someone who is not born without that limb, for example? Like, do we train
Right.
them literally? Can we train them if the brain is
So
not
you
aware this
do.
place is there?
Yeah. You overwrite the language center that had begun to accept that they don't have a hand, and you do this thing with called mirror therapy. So you're using one hemisphere of the brain to overwrite the other hemisphere of the brain to begin to accept it. What's really interesting is when we talk about something like pattern recognition or AI in terms of control, that a person that was born without a prosthesis can actually begin to develop this idea of patterning. They shouldn't be able to, and yet they do, because as long as they're consistent in that, so they use this thing called mirror therapy to overwrite that. So it's pretty interesting how adaptable the brain is. But it can also go the other way where we aren't able to incorporate into what they do, and they just don't accept it, and they just move forward in life using one arm, or they don't use their prosthesis properly.
All right, Gerry. We definitely dove in the deep end, getting going into this section, but I want to rewind a little bit and just talk about how did you get into O&P? We hear all the time that O&P found us. A lot of people will say that, but I'm just kind of curious, how did you get into the orthotic and prosthetic field?
Yeah, I would say I had to actively find it so I guess way back when I was a kid, I just loved the $6 million man, but I didn't want to be the $6 million man. I want to be that Dr. Rudy, what's his name, that put the prostheses on him. And so I thought that's what engineers did. I probably could have used some guidance counseling back in the day, but I thought, well, I'll be a biomedical engineer, whatever that is. I think I saw that in the Milwaukee School of Engineering catalog, and I thought that sounded pretty nice. So I got an engineering degree, and then I had actually seen a fitting of a prosthesis in my hometown. I come from a very small farm town, and I saw the patient fit in Rockford, Illinois. One of the farmers from my little town of 700 was fit with a transfemoral prosthesis. And I thought, well, that's pretty cool. So I kind of kept up with them, and I was able to ask the prosthetist where he went to school, and he said Northwestern. And I said, for engineering? And he said, no, for prosthetics. And so I kind of kept in contact with him. I wanted to get married and have a family. So I started my life. My wife and I got married, and I worked for Baxter Healthcare as a design engineer for Baxter Healthcare for surgical instruments. And it was good, but I felt like I needed to get back to what I started. So I took a tour of Northwestern, and everything just seemed to open up. I was thinking about internal prostheses like hip joints and knees, but then all of a sudden this career just opened up. So they let me come and take a tour. They said, you'll have to beef up your, anatomy and physiology and biology. And because I was an engineer, and I was one of the first engineers in the profession that made a career change. So I had to actively pursue it. And then I really loved school. I even created little simulations that taught how to laminate, because I thought this was a wonderful process. But I made a game out of it, similar to these like little hypercard games back in the day. And they saw this and they thought this was pretty neat. So after my residency, they asked, would you be willing to come back as an instructor at Northwestern and, learn and teach, but then do a clinical simulator so that, people could learn how to fit patients properly. So I did that. And there was a grant, and I created this little program called the Student Interactive Prosthetic Program. And they had little offices they would go into and fit the patient. So, and then I happened to really enjoy teaching. So that kind of expanded. And then I was in charge of, back then, the CAD-CAM program, ShapeMaker. And so we had the students make one of their transtibial devices on that. I would help them and teach them that. So it was a great application. I got to see as an engineer how alignment works or doesn't work, or what load vectors were. And, I could apply my engineering knowledge and material science knowledge, but I really enjoyed communicating that. And then later, as a product development and education coordinator, and then VP of product development for PhilHour, and now as the national director for clinical affairs at Ottobock. I've been able to kind of incorporate those three things that Dr. Childress talked about: being really good at development / research, care, and as well as education. He said if you could be equally good in those three things, your career, that would be the dynamo that could run your career. So that's really my history.
Wow, that's great, and that's amazing. And I noticed that you just glossed over the CAD/CAM part. So tell me what year that was, and what you were doing in that, and were you doing any 3D printing in the prosthetic stuff? And then I want to hear. I'm guessing there was some 3D printing that was happening in your Baxter days as well.
Yeah, when I was at Baxter, I worked so I was used to stereolithography. We would spend money for molds. And back then it was using a laser with different layers of pre-impregnated resin paper. And then back then, I don't know if this is a funny story, it'll have to be edited out, but we made this thing called a rectal specula for proctologists. And it's kind of like a spoon for their fingers. And what we found out, because we bought all these forgings from different forging houses in Germany, we found out medium was bigger than large, but we didn't know that until we had it 3D printed with the stereolithography. And so that was, I'm sure many people benefited from that, from that knowledge. But when I was at Northwestern as a teacher, I always thought, well, this is interesting. This is the land that time forgot, because they were just getting into microprocessors and CAD/CAM and printing that. And printing directly from a virtual image was still kind of new to them. Well, to me, my first internship was for Ingersoll Cutting Tool. We made custom cutting tools. We went all the time from a virtual wireframe to to cutting it out of metal. And that was not a big deal back in 1991. Actually that job was 1989. We used CADM. It was a wireframe program, and they had to make special devices or special cutting tools for the automotive industry. And then later for the surgical instruments company, we used a Macintosh-based system. It was one of the VersaCAD. It was really for architects, but we used it for machine shop. And so it was nothing new to me. So when I was a teacher, I came back in 1992 and 1993, sorry. And we used ShapeMaker back then, but we still had to carve it. And it was this old Acorn lathe that was made in England, and we had to use, plaster that was reduced in density with cornstarch. And it would always get this, you would get the corn smut in it. And I was used to the corn mold because when I would grow up in the farm country, you'd see corn mold everywhere and sometimes wet corn. And so that's what happened to those cornstarch models if they were out too long. And it looked like green cheese and it smelled a little like it too, but I would help them carve it. I remember one day the carver kept carving this little tiny thing at a little dimple in it, said it was done. And it did this 3 times, and I asked the student, "What did you do?" And he said, "Nothing." And then I realized he cut the reference from, it was carving it at 1/10. So it was making this little tiny kernel at the end of this giant mold. Anyway, that was kind of interesting. And that's where I got my first understanding, application. And then Josh Rolock was there, just happened to be there at the time. And he was doing this thing called Squirt Shape, where he was using a machine tool and carving, not really carving, it was additive. And it was carving polypropylene or putting polypropylene bead and in a spiral, and then with making transtibial interfaces. So we actually fit one of our students with it back then. And, I was a little surprised that people were surprised by this because, we had been sending, models to machine tools for a long time, but Josh was one of the first to do that deposition. And then PDI bought that technology later.
Wow. So ShapeMaker, early 90s. Do you know any of the history of ShapeMaker and how it got there?
And David Boone. Really, it was intended for the third world. I mean, they're very altruistic people, and they were thinking what they would do is just get the shapes. They would digitize the models, either positives or negatives, and send it back to Seattle where it was originally made, and would be modified and sent back completed devices. And I think it's actually kind of what we're doing today. So yeah, they were big thinkers. David Boone is a CPO, PhD now. John Harlan was a kind of like me, an engineer who also knew prosthetics. And what was so interesting is they didn't try to change prosthetics. They took what people knew in terms of how they modified in analog form, and they just adapted it. So they even had like a little sanding tool, and then they could create landmarks and topology. Much of what we understand about current CAD systems really came and evolved from ShapeMaker, and it still functions, which is kind of amazing. You can still get it with ProVal Digitizer and Carver.
So it seems like, that product got orphaned essentially. Did that go along with the Hanger acquisition, or where that product actually landed?
What supplanted it was BioSculptor and Greg Pratt, who was a game architect, and he was hired by Alan Finiston, was also a great forward thinker. The problem with ShapeMaker is it always still depended on a cast. You still had to take a cast and still had to mark that cast. And so there was an additional step, whereas BioSculptor let you actually scan on the limb. I remember seeing this in the AOPA meeting in Cincinnati. It was around Halloween time. I remember because everyone was dressed up, and Greg Pratt was showing me how to use this, and he was scanning directly from a leg onto the screen, and he was using, the positional system that they use for helmet placement, for head-up designs, so it really became the Prolhemus type scanner. And then I think the reason it became orphaned, it was just the innovation jumped the scanning capability of it. because
Gotcha.
but I think what happened was Hanger bought them, and then I think it just existed by itself. And I remember a young Chris Robinson, Sheck and Cyrus actually purchased ShapeMaker, I think, in Chicago. The program, or at least could distribute it. And so I remember meeting young Chris Robinson that was showing all the upgrades he had made with ShapeMaker. But you could get it. It was on a small floppy disk. It was 1 megabyte.
Wow. Yeah. Incredible. You can't even get your USB stick to work for out of 1 megabyte and nothing.
It was on one little floppy disk. Yeah, it's 1.14 megabytes.
That's amazing. So you did talk a little bit about, and you touched on this, and I find this very interesting, is you talked about with ShapeMaker, you have to take a cast and then you bring that cast in, and then BioSculptor was more direct scan, with Alan being forward thinking and such. Do you have an opinion either way, direct scan versus cast? Or what are your thoughts along that? I know that can be kind of a hot topic.
I'm always guided not by the dogma of the tool, but the application. So I think it really, not to give an answer that's not committal, but I'm an engineer, so I try to use what's the best tool for the right application. So I think for most shapes, if you can get an approximation based on the measurements and the algorithm can create or kick out a shape that looks pretty standard and the limb shape is pretty standard, I think it works just fine. I think it's when you have really unique custom shapes that have invaginations or odd presentations, then you probably do need to get that shape digitized. My daughter is a sculptor, and she says that typically they will shape things in an analog form and then digitize it and then alter it. So they kind of use more of a hybrid approach. And I've seen this as well, that you get the basic shape into the system and then you can alter it electronically. So I think it really just depends on the patient and how you're going to manage them. So I don't think it should be a hot topic. But what's so interesting looking back on it, though, is that in terms of use of 3D systems, everyone thought it was going to be one system for all, one ring to rule them all. But it never turned out that way. We used CAD differently for transtibial versus transfemoral versus any other shape. And so I think that really is kind of cool, right? We adapted the tool to meet the needs of what the patient needed. So we just use it differently based on the level.
And then now we went from carving and now we're actually able to 3D print. And you mentioned the PDI squirt shape stuff and just how big those beads were on the resolution. When you fit that patient, what did they think about those kind of
it was
beads or lines?
Kind of interesting because the bead, the actual bead was like 1/4 inch, but by the time it was laid down, it was probably 1/8, And I don't know if you've seen like those 3D printed homes where it's just the tool is moving along it. And then, you have this little ridge. When they put it on, they actually said it felt like it stimulated their limb. Of course, I think they were wearing a 5-ply sock, right? Mm-hmm. We tried just for fun to see what it felt like with a sheath. And I remember the process name was Lee Carden. He was a student, actually, now a prosthetist. He said it felt like it stimulated his limb, but he also feel like he didn't lose suction. So I was thinking, how crazy is this? It's just like what Carl Kasper's described with his system, right? With the dimples and the little prominences. Mm-hmm. It kind of, what it did was it wicked the suction around a little bit more. So they said it was fine.
Mm-hmm. Wow. That's amazing. Did they do any long-term walking on it or anything, or?
Yeah, I mean, they made polypropylene systems, and that's why the PDI lock had to be made the way it was to fit that as a little puck. It had to be a regular shape. So, yeah, they said when they walked with it, because it was regular ridges, it wasn't irregular. They didn't really notice any, issue on the anterior distal tibia or anything like that. I imagine if they had thin skin, though, Lee was not particularly. He had good subcutaneous padding, but he was fairly short in terms of his limb length for transtibial.
Right. Wow, that's wild. Well, what do you think about kind of just fast forwarding to today and where you see some of the 3D printing stuff, what do you like? What do you don't like? And is there, so just to give you a little context on the question too, is I was a very anti technology prosthetist up until about 2014. I really thought that people that used technology, it was a crutch more than anything, as for the people that didn't have hand skills, right? And boy, was I mistaken on that. But I mean, I learned a lot of lessons along there. I liked your answer previously on, I don't really care how it's made. It's really what the outcome looks like. And I would say I've fallen in that camp too, is really 3D printing is just a medium on how good is your evaluation and your shape capture and how good are you at fitting, and the rest in the middle, it doesn't really matter. So I'm just kind of curious your opinion on where we are now, state of materials and technology, but then also state of the clinician aspect of that.
Yeah, as an engineer, I think I was taught to, maybe I still, I don't know. Yeah. I steer clear of values, right? Right, wrong, good, bad. It's what's best for the accomplishment of that task, right? So that's the biggest thing, is that I just need to know. I need to know what I'm doing. Is it the most efficient? Is it the highest quality? If I could say something bad, is that what you mentioned, this technologic seduction. Just because I scanned it doesn't make it better. In fact, a negligent prosthetist can use CAD, and they could just make things, poor sockets, poor fittings, poor orthoses faster. So it's really just about being a thoughtful clinician is number one. I do think that it does help when you're embracing digital technology to understand this really tough variable. And I got to tell you, I'm still so impressed with it, is that patient's skin and volume is so different from patient to patient in orthotics and prosthetics. How the tissue responds to loading and the perception of it is just so different from patient to patient. And sometimes it does help to do an analog process to just understand that a little bit better, to understand how sometimes certain areas, just small changes can mean a lot. And then other areas, small changes mean very nothing. So I think it's important to understand how that fits on this patient, to understand that. So I would say what I don't like is when I think people think, oh, I'll just take a few measurements, and then if it doesn't fit, then it's the program's fault. Well, the thing is, you didn't really prepare the program accurately. It's your fault. It's your fault for not, no one blames the hammer if you miss the nail, right? So, but we do this all the time in O&P. We blame technicians that aren't there. So we blame the CAD system for not capturing the scan, but you have to really kind of practice with it and get good with it. And so whatever you're doing, if you're scanning, you have to be very critical of yourself. It doesn't matter what you're doing. Be very critical of the fitting and see how you could personally improve the way you do it. And I think that process of getting better at what you do with every time you scan, every time you modify, is critical. Now, what's that got to do with CAD? Nothing. That's a mindset. That's like you saying, I'm committing myself to doing better. And I think that's sometimes what prevents people from jumping over that technological chasm, is they have so much confidence in their hand skills, loading the patient. They don't know how that will translate digitally. But they should try to like change what they do, because it really benefits the patient, as if only to document what they've done is really important. But I think everyone has different perceptions of risk, and that's what a real issue is. If your perception of risk is very high, you feel insecure or think technology will fail you in some way, then you're less apt to make that jump. But if you feel like you see the benefits and you see the advantage, and at some point in 2014, something happened to you, Brent, that made you say, you know what, I've got to learn more about this. And maybe you saw great fitting, maybe you saw a speedier outcome, maybe you saw better documentation, but something motivated you. There was a little bit of a gap between what you could do and what you could provide and what you felt the need was. And so you decided that was worth the risk. You took that gamble.
Yeah, well, I could tell you straight up what that was, is I had just gotten back from Guatemala, 3 prosthetists, and we fit 63 devices over the course of 6 days, and I was worn out.
There you go.
And I was like, never again, because we did, everything from the evaluation casting to modifying to making all new devices. I remember looking down at my hands, literally having strawberries on them from using the sand screen because I was the one modifying most of the cast. And I said, never, never again am I going to put myself through that much pain. And I just remembered that I wasn't able to spend as much time with the patient
Right.
as what I wanted. And
that's a perfect story. And what does that have to do with digital anything? Nothing. It was you recognizing that you could spend more qualitative time with your patient, that you could do things faster. And if you just had to learn how to do it. So I think that's a great story.
Well, I'd say let's take this and just pivot into some of the work that you do that you're very passionate around, mental health. I do want to touch a little bit on your dissertation, so maybe that's where we should go next, and then finish up with kind of the mental health safety. You mentioned burnout and quiet quitting and all that stuff quite a bit, and so we can touch on that next. So let's jump into your dissertation, because you did kind of foreshadow that in this last part, and then we'll move on to the kind of mental health and work safety and that sort of thing.
So my dissertation was really, I've always been interested in what we were just talking about. Why do people take the risk or the gamble to innovate? And my feeling was like, well, does this have something to do with group dynamics or perception of anxiety? And anxiety is really any sort of perception of threat. And then chronic anxiety is that perception over time. And that threat can be real or imagined. You can have a threat of a lion or tiger trying to attack you. That's a real threat. You can also have an abstract threat in that you're just not able to serve all the people you want to, or in your case, very tangible, you have sore hands, So there's a perception of anxiety that I can't overcome this. And so I wanted to study, I always knew that certain groups seem to adopt things faster. And so I wanted to know, why do certain groups innovate more than others? I always felt that this was true of people, of groups, of myself. And so I thought my original theory was that higher levels of workplace anxiety would cause an effect to how quickly they adopt innovation. Well, that sounded all great. I wrote it all up. I did the study with a survey on OMP listserv. And what I found out was something very kind of impressive, that it didn't. It was impressive. Science is always great when it does what you want it to, but it didn't. What I found was there was only a very small correlation between people who decided to cut off from one another and had extreme anxiety. So innovation is a social process. It's a social communication process. That's why we decide to innovate from person to person. So what I found was only 0.3 correlation, though, in terms of 1 being highest, 0 being the least. There's only 0.3 of anxiety to innovation. Well, now I'm depressed. I was depressed for about a week, actually, because now I think I have to start this whole dissertation over. I have to choose even a new topic, right? No one's going to give you a doctorate for 0.3 correlation. One day I was just kind of playing with different types of numbers, and I flip-flopped anxiety and innovation as to what had an effect on the other. And what I found was something kind of interesting. What I found was innovation had a far greater predictive impact on anxiety. It was like 0.53. And in behavioral terms, that's pretty significant. In biomechanics, it's not. But behavioral terms, it is. That's a strong correlation. So the more I looked into it, what it means is that innovation helps people be less anxious. And I had to think about this and go back to my beginnings as a teacher. When we challenged those students repeatedly every day with a new project at Northwestern, and it was a fast pace. We did prosthetics in 4.5 months, orthotics in 4.5 months. There was no time for any anxiety to build up because you just simply had to respond to the needs. So there was very strong dyads between lab partners. These lifetime friendships are something they still recount to this day. So then I found out that actually having people work on new projects, when that ADHD boss comes to you and says, hey, guess what? We're going to go paperless next week. That actually is a good thing, because the groups that are able to say, okay, well, that's what we're doing this week, I guess, are able to adapt more quickly. It's not that they don't argue. They argue all the time, but they know how to argue, and they just get used to the fast-paced anxiety that innovation presents, so that's not as chaotic to them. They're more, they have a tougher, not tougher, but they're more receptive to the being flexible in the face of it. So that kind of grew into this idea that it's really all about relationships. I looked at people who were task-oriented people, and then people who are concept-based people, like business people, and then human relational people. And we have 3 distinct groups. What they all did was they chose between, if I want to do a transformative thing, is it a task I look for, or is it a relationship? All 3 of them, in O&P anyway, rated relationships number 1. And then I started thinking about, in terms of adoption of upper limb prostheses. And what I found out is that the comfortability or the confidence of the prosthetist has a strong impact on whether or not that patient will adopt that device. And that's why the acceptance rate is the same as from 1958. The acceptance rate for below elbow, above elbow, trans shoulder disarticulation is almost the same percentage point, only changed by 1 or 2 points. So technology wasn't the big thing, but the difference was how well that prosthetist felt like they were a specialist. So this kind of opened up me looking more and more into not the components, which I started my career developing. I did do this, but I've started thinking it's the state of mind of the prosthetist, the clinician, and the patient working together that has a far greater impact. So this led me to this idea of, I was looking at, do people have, when we're talking about the relationship in school and then now as clinicians, how does this have an impact on overall patient performance? And I wanted to know, do we have too many clinicians, too few? What I found in the comments section, there's people expressing a lot of burnout. They said that they're not seeing more patients now. What they're doing is just having more paperwork. And they also talked about this discrepancy between how they're evaluated as clinicians versus how they evaluate themselves. And there was a difference. Prosthetists and clinicians like feeling effective. They adopt new technology. But the rest of the world, sometimes their managers look at the revenue they're generating. So very different values in terms of these groups of people. And so I looked at burnout, and I found out that burnout rate was exceedingly high. Part of that was my burnout survey was after COVID. The other survey I had done that predicted the burnout was right before COVID. And it looked like that burnout rate had really rocketed up. And especially among a group I did not expect. The second, typically 11 to 15 years is when you're of experience, is when you're at the lowest level of happiness. You'll see this decline of happiness. It even affects whether or not people use certain types of components, right? Liner use or transfemoral socket design. But you'll see this decline of innovation and happiness to about age 55. And then you see an uptick to retirement where you're at half the level when you started. What I found with the burnout rate, the second highest was 0 to 5. They should be the happiest of all. Wow. And yet they were second highest in terms of burnout rate. And they cited debt, and they decide the amount that they're supposed to know, because now they're all CPOs. They're not one or the other. They also cited management giving them unclear values, or they don't really give promotions or raises. So this led me to ask more questions about all of those things. And then most recently, I'm looking at quiet quitting, which is pretty darn high right now. And the scary part is we're seeing an attrition rate of clinicians. So the question is, if they're unhappy at 0 to 5, what happens when they do reach 11 to 15 when times are hard? That's not going to be, we're going to have an attrition rate. And that impacts, people might say, well, that's great that you care. It's altruistic. But that's going to impact how well innovation is placed in the market, how well they use that innovation and how they use it together.
That's amazing on the 0 to 5. And I mean, I see that firsthand. I mean, we've got some amazing residents, and when we talk about their classmates and that sort of thing, they'll talk about, hey, their classmates aren't even going to sit for the exam. Like they're done. They're going to go back to engineering, whatever. This is
right?
and I just it's amazing to me.
It's daunting, and it's something that we really need to pay attention to. And it's not just, oh, well, it's some people say, well, it's a generational issue. Part of it is, but I certainly did not have that debt ratio that they have now, and they have to manage that. Also, we usually started out as prosthetics or orthotics, and they're expected to know all of that and double the documentation. So it kind of does. And then this whole issue of how they value themselves versus how the rest of the world values them. If it's all about revenue and increasingly it's a transactional world, then that takes away some of the really wonderful things we get to experience as clinicians.
Yeah. And it also puts them in a hard spot too. You want to be able to cover your debt, and you want to make a house payment or buy a house, start a family, that sort of thing. And so when you have a salary like that, those transactional things have, in a sense, have to happen, because you have to have an income to support your salary. And what does that ratio look like? And it can put some stress on not only the company, but then also the person that's working for this company. And it just seems to be like a cyclical thing.
Yeah, most definitely. And it's increasing. And you can't just cite, oh, well, they don't know how to stick it out. Actually, what's happened is that the stakes have just gotten so high that they're making a choice economically and qualitatively if this is going to be a profession for them. And in a real sense, they're making that choice. So the thing is, you got to pay attention to what's happening. So I've been telling people about it, but people, especially my age or older, that they really need to take care of this for the good of the profession, but also in the end for the good of the patients as well, because practitioner retention also predicts patient retention. If your clinician walks and goes to another office, they're taking those patients with them eventually. You can give them a non-compete, sure, but those patients find a way to find that person.
Yeah. And I think that's probably one of the most interesting things is it really doesn't matter the name of the company that's on the outside. It is all about the clinician and that relationship, the clinician and patient relationship. And I think that's what makes it difficult for people kind of on the outside that look at O&P for investment or what have you. It's to wrap their mind around this idea of relationship, patient, and clinician.
Yeah,
It's hard to put a dollar amount on that,
Yeah. Well, nursing and physical therapy, they have. And the cost to drop out and burnout is exceedingly high. And I think actually, when you look at, there's a graph I found of comparing the different levels. Our burnout rate is higher than OTs and PTs. We're right there in terms of the instrument you use to measure anxiety. So, they're making that choice. So you should pay attention. And it's also, how they incorporate the innovations that we want to do. Are they more flexible when they're anxious? Nope, they are not. They're pushing back, and this quiet quitting rate, quiet quitting rate is around 23% of your group. 23% of any group is actually quit enough that it's noticeable. And the thing is, 23% of the people listening to your podcast are the same way.
That's amazing. Yeah. I think the other thing that's interesting, and kind of want to get your perspective on this too, is it seems like, I say our generation, I mean, I started in prosthetics in the mid 90s as a technician. And so it was always, before hours, after hours, even my residency. And I love that this kind of new generation of clinician is pushing back on some of that. And they're like, no, I don't want to, I don't want to work that hard. They're going to work hard during a specific time, but they also want life to happen, which I definitely appreciate. And they also want to be very good at their craft. And so I'm excited about this next generation. I do think it's kind of curious, though, that a lot of what I've seen as far as people, they are good clinicians, but they don't necessarily want to make a jump into a management or leadership sort of position. And that's not even on their radar or 5-year plan, like it was for my generation of clinicians. So wanted to just see if that's something that I'm seeing, or is that something that you see as well?
I think it may be only in that the rate of ownership is less. So the possibility, the thought that you would be an owner was much higher when I was young. And this entrepreneurial, I'm not saying that was a good thing either. I mean, we had people in our class talking about, I see you guys as future competitors, whatever, dude, but this idea that I have ownership, or I will ascend to ownership, or I am differentiated enough. A lot of people want to just do good work. I think they do set boundaries well. Their boundaries have to be set because the stakes seem higher in a way. They're really having to set that. And the thing is, people from our generation, if you want to say, we still did it anyway. We just didn't say it. We didn't really say it outwardly. But when we needed to take time off to go see our kids' soccer game, we did it, but we just didn't give it a name or term, and we didn't state it clearly and emphatically. In many ways, this younger generation too, they never stop working. They're working as long as they're awake. They're also playing as long as they're awake too. So this work-life separation doesn't occur because that just doesn't occur to them. So like I used to get a call from a younger prosthetist. She would call me at 8:30 at night on Sunday because she had just thought of something. And if I decided not to take that call, then she'd forget about it the next day. So that was just part of kind of what they do, how they work differently, but they are willing to call it. I think this sense of ownership is important because they feel like, well, if I'm not an owner, am I paid enough to care that much transactionally? Owners would like everyone to feel like owners, but not give them ownership. That's the problem, and I think too, when we were younger, if you were a star player in a company, eventually they would get around 11 to 15 when you could leave and you're very proficient, they would give you ownership, but they don't do that as much anymore with consolidation. So I think people are just saying, well, fine, I'm not an owner. So why should I care that much?
Yeah. I think the other thing that's been interesting on the education side of things, and Chad Duncan at Solace has done this well, and others, I have seen residents ask the question why, and it's not in a demeaning way, like, why did you do it that way? But like genuinely curious, why did you do it that way? And I know that there's some older prosthetists that don't like that question because it's just, hey, that's just the way we do it. But I know for me, is a difficult thing to, I love the question and I love that way of learning, but it also was challenging for me to talk about the actual reason why I've been doing the thing, for the last 20 years, the way I do it, or what's been the journey. So I just wanted to get your also opinion on the style of learning and teaching as of late, or even some of your experience while you were teaching at Northwestern.
Well, part of the issue is kind of it's related to economics of teaching. So a lot of the clinical experience has been shifted from being done in the school to being extrinsically in the residency. And the reason is to decrease the amount of cost it is to, teach people. But then there's been some unintended consequences as with any technological change, innovation change. So what's that done is it's shifted much of the practical education to those who've never been trained to be a teacher. It's part of the thing was when you were teaching at UCLA or Northwestern or New York, you needed 1 or 2 years behind you to really learn to teach. You need to be taught to be a teacher. And so then you kind of went into a group with a smaller patient, student to teacher ratio. I think I had 6 students at any given time. So I could really spend a lot of time not only teaching them, but learning to be a teacher. So what they did was that the residencies, they shift a lot of this practical clinical teaching to people that really weren't trained to do it. And so they didn't equip them necessarily to be teachers. So then they're a little uncomfortable giving direct answers. Whereas at Northwestern, there, or other schools, there was a set recipe that you had to follow. We said you can do something later, but right now just follow this recipe so we could track where you're at and we could answer those questions better. Sometimes students are doing all kinds of different things. They've cast it a different way and they maybe painted themselves in a corner when we weren't looking. But, someone that's not been trained to be a teacher doesn't really know that. So part of it is due to the educational system. So people who are mentors, if you want to be an even better mentor, you need to kind of get back to the school at, Baylor, Salis, Kennesaw, Northwestern, and maybe check in with them and really learn how to be a better clinical teacher. But here's the thing. When do they have time for that? I mean, they're certainly not going to be paid for that, And so that's part of the issue, I think.
Yeah. Yeah.
They need that time to make mistakes in a very safe practice field, but they need to follow the scaffolding of the curriculum well so that they can be tracked. And then as time went on, in our semester, we would release people who are more advanced so they could experience more things. We'd take the scaffolding away. Other ones, we might have the scaffolding on them the entire semester.
Gotcha. Well, let's kind of just finish up on this idea of mental health. I know we've touched on it a little bit, but for the orthotic and prosthetic field kind of moving in, and what do you see as healthy, not only from like a business owner standpoint, but even how companies can help support clinicians and moving that forward, and just overall awareness around this idea of mental health. I know, even some of the older clinicians, we know it's a real thing, a real issue, but sometimes it's one of those things you don't necessarily want to talk about it. So can you just dive into that and talk about that specifically in the orthotic and prosthetic industry?
Well, we, as you mentioned, Brent, we sit 2 feet away, nose to nose with the patient. They impact us, we imprint on them, and they imprint on us tremendously. And it's both good and a bad thing. We carry a thing that they call emotional labor. So we, as a person, embody that, our group, right? I was told one time, Gerry, my German teacher said, Gerry, even if you're not that confident, you got to seem confident with your solution, 'Cause they're taking a step out in space and that leg's got to be there for them. Gunther Gale used to tell me that. So we have to project this halo bias optimism that the patient will succeed, even if we're not quite sure. This actually creates what we call a double bind. We're not sure it will work, but we have to say that so that it may work. It'll have a chance of working, but also that we represent the group. Flight attendants have the same issue. Teachers, people in the clergy, customer service, they have to be happy, optimistic, even when the patient is not. And this is emotional labor. This creates an issue where we have to have one face on, during the day, and then another face when we're with our families. So this creates a little bit of an anxiety because we have no control over even how we appear. We have a double life. We have our inner life and we have an outer projected life. This affects us quite a bit. The other thing too is being responsible for others. Nurses have an out of control burnout rate because they're responsible for others, and not necessarily is that going to correlate to your success in terms of how well you're promoted or what you do. So sometimes even the most caring people in any clinical setting are not necessarily the ones that are promoted to manager. In fact, probably the opposite. Your regional manager may not be the most caring of people. So what this does is kind of create another false sense of correlation, so we're on 2 different career ladders. The other thing too is that some groups, they're not very cohesive. They don't communicate particularly well. They let people kind of become islands. So that's when you're on an island, you're really not doing well. And then you're very susceptible to the burnout rate. So the burnout rate in O&P is all of us, on average, all of us are at risk. All of us are at risk. Right now, we score around a 43.12 or whatever. One in three of us are burned out to enough that it's beginning to affect us mentally. So we're not able to remember things as quickly. We're not doing things as much as we used to. And then 1 in 10 of us are just done. We're done. We're ready to go do something else. We're ready to go remodel houses, put down carpeting. We're ready to leave the profession. That costs any group, especially mom and pop, which is most of the profession still. It's about just over around 65% is still mom and pop. And some of those are the worst. You'd think, okay, well, it's got to be the corporate entities that are hardest to work for. Actually, there's some oversight and some instruction about how to treat people. In some of the mom and pops, there is absolutely none. You are an island. You are on an island.
Right.
And here's the thing. What the biggest difference between a specialist at a larger corporate group and someone who is at a mom and pop is that the specialist talks to 5 times more people outside of their office. And this is encouraged in the corporate setting because that's what makes an upper limb specialist or a orthotic specialist or any specialist, cranial specialist, is that you're talking to people outside of your local group. If you're off on an island, not only are you prone to anxiety, you're just not going to innovate particularly much. There's just too much risk to you personally. That's why, between you and I, the people sometimes at the mom and pops, the people that are using the most expensive devices are usually the son or daughter or relative, because that risk is tolerable. They're part of the family, right? It's not necessarily they're good at it. It's that the company, if you're going to use a myoelectric arm, they trust that you're going to do it and the company won't go under.
Right.
So this is a real issue. You can't let yourself be separated. And people that are older did suffer incredible crushing anxiety. They just never talked about it because it was something people just didn't want to believe existed. It did exist. It did affect them. And some of them actually became really bad clinicians as a result. And that is something that younger people, like you said, just won't tolerate. That is a good thing. They say when this isn't right, that this is unjust. And, to accuse them of not being as tough, I think they're just more vocal about some of the things that used to happen, which were bullying and mobbing, stuff that Tom Kerlewski studies.
Gerry, thanks so much for being on. This was great. We could go on forever and ever. And I want to dive into some history sometime in the future too, on just socket design and all that. But this has been great. And so I really appreciate you coming
Thanks
on.
for the invitation. And thank you to all of your listeners and Mr. Joris and everyone.
Well, thank you for listening. This has been another episode of the Orthotic and Prosthetic Podcast. Have a great day.